told you my good joke. So we're done for the day with jokes. So in any case, you have in front of you a radian man, and you have, so the radian thing, that's basically a unit circle, and you're going to fill that in and make it look pretty, and if you make it look really pretty, I'll give you a couple extra points. I'll color it and make it into something special. But you will have to reproduce the unit circle eventually, but right now we're just going to look at this and go through the first part of that table that you have on there. So a unit circle is a circle with a radius of 1. That's why it's called a unit circle. Okay? And then to get to any point on the unit circle, you go over x units and you go up y units. Okay? It is convenient, and these come up a lot of times, to use these two special right triangles that you might or might not remember from geometry. You remember those from geometry? That so if this side is 30, then and this radius is 1, this is the radius of your circle, then this side comes out to be 1/2. And that comes from the fact that I could draw in an equilateral triangle here, and so this would be 60, and so this side would be 1/2. And then if you do the Pythagorean theorem, you can simplify and you get that this leg is going to be equal to the square root of 3 over 2. Okay, but that's where that comes from. And same idea goes with this, right? If you have a 45, 45, 90, and you use the Pythagorean theorem, and you call this x squared and this x squared, you get x squared plus x squared equals 1, right? 2x squared equals 1. X squared equals 1 over 2, x equals the square root of 2 over 2, which changes into that. That's where that comes from, okay? So then you basically use these two right triangles to find pretty much every point on this unit circle, except for the points at what are called the quadrantal angles, which are this one, this one, this one, this one, and this one. So those are the ones that are neither in the first quadrant, second quadrant. Oops, they're not in any quadrant. They're just, how do I get rid of that there? Okay, they're not in any quadrant. They're just hanging out here on the axis. So those are the quadrantal angles. Okay, so sine function, the mathematicians, they decided that the ratio in a right, you learned this in geometry, that the ratio of the opposites, and algebra 2 probably too, the ratio of the opposite side to the hypotenuse side is sine, right? The ratio of the adjacent, remember SOHCAHTOA, adjacent to the hypotenuse side is 1, and the tangent is the opposite side over the adjacent side. Well, if this radius is just 1, then sine is y over 1, which is just y. Right? So anywhere on that unit circle you go, on a unit circle, sine is just the y coordinate. Right? And for the same reason, since the cosine is adjacent over hypotenuse, and the hypotenuse is always 1 in a unit circle, then cosine is always just going to be the x coordinate. Tangent is still the same as it always was, it's just y, the y coordinate over the x coordinate, because to get to that point, I would go over x units and up y units, so this is y, that's x, and so that would be the tangent, okay? These ones over here, these are called the reciprocal functions, okay? What's a reciprocal? Not the opposite, it's the way you take when you flip, okay? So the reciprocal of sine, even though it doesn't seem like it should be, is cosecant, okay? You would think that the reciprocal of sine is cosine, but it's not, okay? Reciprocal of sine is cosecant. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. And it's just another ratio. So instead of this being the ratio of y over the hypotenuse over the opposite side, this is the opposite side over the hypotenuse. But all you really have to do is flip them over, right? So if you know sine, you just flip it upside down and you can find cosecant. And if you know cosine, you just flip it upside down and you can find secant. And if you know tangent, you could just flip it upside down and find cotangent. So those are the reciprocal functions. We'll talk more tomorrow about the co-functions. Sine and cosine are co-functions. Tangent and cotangent are co-functions. And secant and cosecant are co-functions. And that's different than reciprocal. So you have to understand that there's a difference between reciprocal and co. So today we're just going to talk about reciprocal. Co-functions they're complementary, meaning they're like the sine of this is equal to the cosine of that, and so on. Okay? So now we're going to fill in the first part of our chart, okay? And we're going to see, how could I do this and get it on here? Let's move this guy. Okay, let's see. Can I make it smaller? Let's see if I can make it. Oh, maybe. Oh! Ooh, that looks really good. Okay, so now we got it all on there. We got two things. We got it all together. So on your little chart here, okay, first thing we're going to fill in is everything that corresponds, the first quadrantal angle, which is this one, which is 1, 0. I'm not going to do this entire chart with you. I'm going to let you fill in some of it. Okay, maybe we'll do the first quadrant. So first we'll do the quadrantal angles. So this point, if I'm looking XY coordinates, this is a point 1, 0. So theta radians is how many degrees? I mean, 0 radians is how many degrees? 0, right? What's sine? What's the y coordinate at this point? 0. What's cosine at that point? 1. What's tangent at that point? 0 over 1, right? Y over x, which is just 0. And what's cotangent? Undefined. Do you guys know that already? You know this stuff already. Do most of you know this? Who knows this? Who knows the unit circle? Like, that's good. Okay, should I just sit down and let you get, no. Okay, so the reason this is undefined because it's 1 over 0, right? So this is undefined. I'll just write undefined right there. Secant, right, is the reciprocal of cosine. What's the reciprocal of 1? 1. So a 1 goes there, okay? And tangent is the reciprocal of sine. And this is kind of tricky because well, what's the reciprocal of 0? It's undefined, or if you think about it another way, cosecant is 1 over y, or it's x over y. So if I go 1 over 0, right, I get undefined. So this is also undefined. Questions about that? So there's your first quadrantal angle. Now we're going to go up here. Okay? So this has coordinates 0, 1. Anyone confused about why those coordinates are what they are? Right? If I go around this circle, if I'm wrapping x and y coordinate, this would be the point 0, 1. So this is pi over 2 radians. How many degrees is that? 90 degrees, right? What's the y coordinate up here? 1. What's the x coordinate? 0. What's y over x? So if it helps you, you could do this too. You could write a y. This is what I did with the last class. X. This is y over x. This is x over y. This is 1 over x. And this is 1 over y. So if that helps you a little, that's a y. 1 over y. That's not an x. Y. There we go. Okay? So y over x is going to be what? What's that going to be? Right there. Undefined. Right? And x over y is 0. 1 over x, 1 over 0, undefined, right? And 1 over y was 1, so what's the reciprocal of 1? 1. There you go. Questions about that so far? Can you see that in the back row? Looks like you're okay. I'll post all this so you can see it. Okay, pi. Pi is over here. Alright. So what's the coordinates of that point? Negative 1 and 0, right? So so basically all of these numbers are the same except for the ones. Okay? Because as over here, right? And so this is how many degrees? Pi radians. 180 degrees. Am I in anyone's way? Am I in your way? That happens a lot. See, then I could go over here and I could do better. Okay? And I could look at my screen. That's the way I should do it. So what's sign here? What's the y coordinate? 0. Okay. What's the x coordinate? Negative 1. What's y over x? Y over x. 0 over negative 1, which is 0. What's x over y? Undefined. What's 1 over x? 1 over x? Negative 1. And what's 1 over y? Undefined. So basically, this is the same as this, except that these two things are negative. Questions about where that comes from? No. Okay, so like on a test and stuff, you're not going to be filling in a chart, but I'll ask you, what's the cosine of 4 pi over 3 or something like that, right? So you should be able to use your unit circle to determine those things, okay? So now we're going to come over here to 3 pi over 2, aka, how many degrees? 270 degrees. Very good. Okay? These numbers, the numbers in this row, are going to match the numbers in this row, except all the y's are going to be what? Negative. So anything that involves a y is going to be negative. So I'm going to just, are we okay with this? Negative 1. And I'm going to put negative 1 over here because these coordinates are 0, negative 1, right? And then everything else is going to be the same as these things right here, because 0 over something is still going to be 0. Undefined is still going to be undefined. 0 is still going to be 0. And undefined is still going to be undefined. Let me make sure that's right. Sine of 270 is negative 1. And the reciprocal of sine is negative 1. There you go. Okay? Look, we're almost done already. Questions? Questions? Oh! No yawning. Do you need to stand up and sit down? What kind of pair are you in? Toyota. I have one of those.
Really?
I know. Okay. All right. I have ADD. I get very distracted. So, moving on. Where were we? X squared plus y squared equals r squared, radius squared. Always for a unit circle and for any circle where we're trying to find the x and y coordinate. So now we're just going to work through the first quadrant. Are you ready for this? I know it's a bit. Do you want me to work through the first quadrant? Okay. We'll work through the first quadrant, then I'll do one from another quadrant, and then we'll go from there. So the first thing I'm going to do is I'm going to draw a line. Where's my tools? Here they are. So let's see if I could get an arrow. No arrows. I don't want arrows. I get rid of the arrows. Go like this, go like this. Okay? So the first special angle, oh, we didn't want arrows on it. I thought I told you no arrows. Go here. No arrows. Oh, am I? No arrows. Is that going to work now? No arrows. It's working. Okay? So the first angle that is right here, okay, this is 30 degrees. Or, oh, sorry, I told you the answer. Oh, well. Oh, well. So pi over 6 is also known as 30 degrees, okay? So that's if you take this triangle which is out of proportion, and stick it on over here, right? 30, this 30 and 60 look the same. Shouldn't be like that. This 30 should be small. Okay? So the coordinates of this point, I go over square root of 3 over 2, right? And I go up 1/2. You get that? Why the x and the y are there? So when you're making your radian man, probably what you want to do, a radian girl, a radian ninja, or whatever you want to make, okay? You could write maybe on this line pi over 6 and 30 degrees, and then the coordinates. That's what I'm looking for. I'm not looking for that you put in all the tangents and cosines and all that kind of stuff. So what's the sine of 30 degrees? What's the y coordinate? 1/2. Okay. What's the x coordinate? Root of 3 over 2. Okay. So now we're going to get tricky. Okay. What's tangent? It's y over x, right? So we'll do a little math here. Okay. We'll go 1/2 divided by square root of 3 over 2. Do you know copy dot flip? Do you know that? You take this number, if you're dividing by this number, you flip it, and so you put the 2 up here and the root of 3 down here. Understand what I just did? Hello? I'm finding the tangent of 30 degrees. So that cancels out, and I get 1 over root of 3, and then I still have to rationalize the denominator, because you're not supposed to leave it like that. You times it by root of 3 over 3 over root of 3 over 3, which is equal to what? Root of 3 over 3. That is the tangent of 30 degrees. Okay? Tangent of 30 degrees, or pi over 6 radians, is root of 3 over 3. Cotangent, do you guys know what cotangent is? Plain old root of 3. So if I were to take, cotangent is this one over this one, right? So cotangent, I'm going to go root of 3 over 2 times the reciprocal, it's x over y, right? So times the reciprocal of 1/2, which is 2 over 1. Those cancel out, and I get plain old root of 3. Okay? Easy enough? You should be able to either memorize these, tangent of 30, cotangent of 30, or root of 3 over 3, root of 3. Cosecant is easy, because cosecant is the reciprocal of sine. So do you think that Taylor can tell us what
It's 2.
What?
It's 2.
What's the reciprocal of sine? Can you tell me what the reciprocal? Do you think Taylor can tell me what the reciprocal of sine is?
Cosecant.
Cosecant. Cosecant. Thank you. Okay. Oh, stop. I got so excited. Okay. So this was root of 3. Dalen was able to tell us, and that's 2. This one is a little more complicated. You have to take root of 3 over 2, and you have to simplify it. Okay, so that's just, so you take 2 divided by the root of 3. This is to find secant, right, because that's a reciprocal cosine. And you multiply it by root of 3 over root of 3, and that gives you 2 root of 3 over 3. Okay? That one I can never remember. So that one I always kind of, these two I have trouble remembering. These two, I kind of tell students to memorize, because the tangent of 30, any multiple of 30, or any angle that is within 30 degrees of the x-axis, it's always going to have the same numbers, okay? We'll talk more about that, but it's always going to be root of 3 over 3, and cotangent is going to be root of 3. The reason they're called cofunctions, we'll talk more about this tomorrow, but the reason they're called cofunctions because at the complement of that, the tangent and the cotangent flip, right? So the cotangent of 60 degrees, which is the complement of 30 degrees, is going to be, these numbers are going to switch. So let's do this one first, pi over 3, okay? So pi over 3 is how many degrees? 60 degrees, right? And then sine and cosine, they just flip-flop places, right? Because the x and the y's flip. You understand that? Okay? Sine and cosine up here, when I'm at 60 degrees, I'll try to draw freehand, okay? 60 degrees, so this is pi over 3, and the coordinates at this point are, I can't see it, are 1/2, comma, root of 3 over 2, right? That's the coordinates up there on that top when this angle is 60, right? And so now, this is going to be root of 3 over 2. This is going to be 1/2. These two things flip places, right? Because this is x over, this is y over x, and y over x is the same as x over y over here. So this is going to be root of 3. This is going to be what? What's this going to be?
Root of 3 over 3.
Root of 3 over 3. These two flip places as well, okay? Because they're secant and cosecant are cofunctions. So this is going to be 2, and this is going to be 2 root of 3 over 3. If you don't remember that these two flip, just look at the picture, right? I want cosecant of 60, right? So if I know that these are the coordinates, and I know that cosecant is 1 over sine, it's 1 over root of 3 over 2, which is the same as 2 over root of 3, which rationalizes to that. Okay? No? Who's confused? A little bit? You're not confused, Victoria?
Oh, no.
Okay, you like you were. Okay, so now we're going to just talk about 45, and then, whoops, I gave it away. Okay, so this is 45 degrees in here. Pretty soon we get to do the math here. Okay, what's the coordinates of 45 degrees? It's this triangle right here. So this is root of 2 over 2, comma, root of 2 over 2, right? And so this is, sine is root of 2 over 2. Cosine is also root of 2 over 2. Sorry, my picture's kind of not too clear. Tangent is y over x. So what's root of 2 over 2 over root of 2 over 2? 1. Okay. Cotangent is x over y. What's that? 1. Okay. Secant and cosecant are going to be the same because they're the reciprocals of these two. So let's do that. 2 divided by the root of 2, right? That's the reciprocal. I'm going to rationalize. And I just get plain old what? 2 root of 2 over 2, which becomes what? Root of 2. Root of 2. Do you remember the math cheer, Caitlin?
I remember.
Okay, so now we have to practice the math cheer. You ready? Okay, we're going to practice it live here so that people in the viewing audience could watch it. Okay?
Oh, wait, I wasn't done writing.
Well, we'll come back. Okay, you ready? Do you remember this, Grace? Grace remembers it. She's going to lead us. Okay. Now she's not. How do you say this?
Root of 2.
Root of 2, right? So here we go. Ready, set, and go. Root of 2, 2. Root of 2, 2. Root of 2, root of 2, root of 2, 2. Root of 2, 2. Root of 2, 2. Root of 2, root of 2. Go, Matt, go! All right. Yes.
So freshman year, when we learned this, you almost made me go next door and sing this song in front of the whole class.
I did? I don't
Yeah,
remember.
that's.
Okay, so anyway, that's the math here. We're going to go back. So if you weren't if you weren't done copying, you could go back and you could, whoops, sorry, you could. So I'm just going to do one row with you, okay? Either 2 pi over 3 or 5 pi. Excuse me, that's not quadrant 3. Yeah, quadrant 3. So we already did this one, right? These are the quadrantal angles, which we already did. So you should be able to fill these out from this chart right here. That's that chart, okay? But, so how about if we do this row right here? 7 pi over 6. What's the name in degrees for 7 pi over 6? 210 degrees. This is 210 degrees, right? 210 degrees, because that's over here, that's past 180 degrees by 30 degrees, right? So that's what we're talking about. Who can tell me what the coordinates are in that row?
-1/2.
Not -1/2, that doesn't come first.
-3/2.
Negative root of 3 over 2, comma, -1/2. So notice that, right, these numbers here, anything that is within pi over 6, so anything that's a multiple of pi over 6, this one, 5 pi over 6, and 11 pi over 6, they're going to have the exact same numbers that are right here. Yes? Because it's the same triangle, right? The numbers are exactly the same. The ratios are exactly the same. The only thing you have to worry about whether it's negative or positive in those quadrants. So let's just do this row. So all I have to do is look up here. It's the same numbers that are here. So this is 1/2 root of 3 over 2, root of 3 over 3, root of 3, 2 root of 3 over 3, and 2. Now I have to figure out what the signs are, positive or negative. Okay? So in the third quadrant, x and y are both what?
Negative.
Negative. Okay? So you go negative, right? Negative. And x and y are both negative, and the reciprocals as well are both negative, right? You understand that? So these are both negative as well. Negative, negative, negative. Tangent and cotangent, that's a negative divided by a negative. So what's a negative divided by a negative? Positive, okay? So everything in the third quadrant follows these signs. Yes? Okay? I mean, signs is, like negative, negative. So that's kind of it. So everything with 2 pi over 3, that's going to be the same as this row. You just have to come up with the signs. Okay? There's also this thing. Have you heard this? Students, take calculus. Or Taylor, take calculus. What does that mean? That tells you where things are positive and negative, okay? So over here, people use it sometimes. So everything is, all are positive. Students, S means that sign and its reciprocal are positive. So these are where things are positive. So only sign and its reciprocal, which is cosecant, are going to be positive in the second quadrant. Take, only, what does that stand for? Tangent, only tangent and its reciprocal, cotangent, are positive over here. Calculus stands for which trig function? C. Cosine and its reciprocal, which is secant. Okay? So if you can remember that, you don't have to remember it. It's just another mnemonic. Is that a mnemonic device? Ooh, I said that. All students take calculus. It's just a way to remember where the various trig functions are positive and negative. So I'm going to give you guys time to fill in the rest of the chart, okay? And then you can fill in, you can work on your radian man as well, and then we'll kind of
Check them off.
Yeah, the Radiant Man and the chart and the homework. Okay, so you can work now on the chart and the Radiant. Okay? And that's, am I still recording? Oh, yeah. So I have a second, and I want to look at a sample problem. Where is it? Not that, not that. Where's my tools? Oh, there they are. So, you guys, just to show you, because people have had questions like this on their homework, and I want to just clarify. So, when you get to one like number 9, so number 9 kind of looks like this. You have a circle. Where's my circle? Circle. Where's my circle go? Oh, here. You have a circle, and then you have a point on your unit circle up here somewhere. Okay, there's a unit circle. Hey, can you guys in the back pay attention to this? Just look up here for a few minutes, because you might get confused. So in this one, they have the coordinates up here, which are -8/17, comma 15/17. And you go, wait a minute, and they ask you to determine the exact value of the 6 trigonometric functions. And hey, Peyton, look up here, okay? Look up there. So even though this is not one of the points that we just found on our unit circle, it is a point on the unit circle. It's because if I did Pythagorean theorem, this squared plus this squared, this comes out to be 1. Believe me. So if I did this squared plus this squared, I think the denominator is 289, and it works out to be 1. Okay? So then, put your phone in the cell phone line.
Me?
Yes.
Right now?
Yes. Okay. So then they ask you to find the 6 trigonometric functions. This is x, this is y. So you just say cosine is -8/17. Sine is 15/17, right? Secant is 17/-8, or -17/8. Cosecant is 17/15. Tangent is this over this, which is going to be 15/-8, and cotangent is -8/15. So that's all they're asking you. You don't have to do a whole lot of math. It's just different coordinates. You're looking confused by that. No? Yes? So this is x, this is y. So the relationship is still the same, even though they're not exact multiples of pi over 6 or pi over 3 and all that kind of stuff. It's just a different angle that you're talking about right there. So I don't know what that angle is, but this is a point on your unit circle. Okay, so that's just that, and that's it. And now you can